Hello everyone. This is Sudhanshu Sarkar, Assistant Professor, Department of Electrical Engineering, Navla Institute. Today I am going to give a lecture on switchgear and protection subject. The subject is designed for third year electrical engineering diploma engineering students. So this subject is very important for the students because the subject uh, helps the students to become a good professional engineer, because in all the time in the system there should be some fault, and if the students don't know about the fault and how to solve these faults, so it will be difficult for them to survive in their professional life. So this subject is basically helping us, helps the students to understand about the faults and their protection schemes of power system, or you can say in electrical system in broader sense. Now, here the lesson plan, if you follow, you will get the lesson plan for this particular subject. In Unit 1, there are some fundamentals of switchgear and protection. So under that, there is a necessity and function of protective systems in normal abnormal conditions, types of faults and their causes, use of current limiting reactors and their arrangement, then short circuit KVA calculation for symmetrical faults. These are the, then in Unit 4, uh, there is some equipment protection. So in this way, uh, there is a syllabus and also the lesson plan is also there. Now today's topic of discussion is potential transformer. Okay, so potential transformer is a short form. The short name of potential transformer is PT. You all know that. So here, let me talk about the instrument transformer. So both CT and PT are under the instrument transformer. So let me talk about what is the instrument transformer. First, a transformer that is used in conjunction with a measuring instrument. So that is actually called the instrument transformer. The transformer that is used in conjunction with a measuring instrument. Yes. Secondly, it utilizes the current transformation and voltage transformation properties to measure high AC current and voltage. Okay, so what is actually it is doing? It utilizes the current transformation and voltage transformation properties to measure high AC current and voltage. Then they also provide isolation. So these are the main part, or you can say the property of the instrument transformers. Now, why to use instrument transformers? So I think you all have some basic idea about the instrument transformer. So to measure high current and high voltage, in these two cases we can use the instrument transformer. Now the question is, why can't we use a voltmeter with very high series resistance and ammeter with very low shunt resistance? And so what is the answer? Now, disadvantages of shunt and multipliers. Shunt. Time constant should be same for meter and shunt. Power consumed increases. Insulation problem is there for high voltages. No isolation. And multipliers. The disadvantage of the multipliers is actually in series resistance. One of the major disadvantages is power consumption. Then there is a chances of leakage current. So good insulator used, hence costly, need to be used. For that reason, the cost become very high. No isolation schemes. So these are the disadvantage of shunt and multipliers. Now, as I mentioned previously, the types of instrument transformer. There are two types of instrument transformer. One is current transformer. That is the short form of current transformer. You all know that it is CT, and the second one is a potential transformer. That is PT. Potential means voltage. You all know. So now about the current transformer. So here, this is the symbol of a current transformer. Symbol of a current transformer. Now conceptual picture of a current transformer. Okay. So secondary is usually 5 ampere. This is standard value for the current transformer, and 5 ampere it is sufficient for a relay to operate and for a meter to measure. So we normally use CT for the operation, for relay operation, and secondly for a meter for the measuring purpose. So for that reason, the 5 ampere is the output, and for that reason 5 ampere is sufficient for relay to operate and for meter to measure. So these are the two reasons for 5 ampere in general cases is the output current of the current transformer. Now here point to note about CT. So to handle a CT or to know your knowledge about the current transformer, you need to know some idea regarding the CTs. That is the first one. You have to remember some basics idea about the CT. So the first one is the primary current depends on load, but not on the burden. So this is the first point you need to be remember for current transformer. The primary current depends on load, but not on the burden. Okay. Second one, current coil of wattmeter or ammeter is connected across the terminal of the secondary or relay. The current coil of wattmeter or ammeter is connected across the terminal of the secondary or relay. So the third point, secondary operates near short circuit conditions, and finally one of the terminal of CT secondary winding is earthed. These are the points someone need to be considered when study or use the current transformer. Look here, the third one is secondary operates near short circuit conditions. Yes, so this point is very most important point, and the third plus one is one of the terminal of CT secondary winding is earthed. Okay, so this need to be remembered for the current transformer. Now, types of CTs, you can find here different types of CT which is available in this slide. This is the construction types. So under construction types, this window type, this is bar type, this is bone type. So these are the three types of current transformer you get for the current transformer. That is the we can divide the current transformer as per the construction. So this is the internal winding construction for the transformer. These spheres. Now let me move to the next slide. The construction details of CT. This is the connection, the winding which is given here. So in this way the current transformer basically constructed. Now here this is the constructional details of window CT. Okay. So in case of window CT, there are few construction like first one is layer 1. This is the internal layer of the city. This part here you can see the core. This is the core. The core you can see here. It is the core, that is the internal part of the body, actually the internal part or internal body of the current transformer. Here two layer for is given for the window current transformer. One is the internal layer which is on the surface of the core, and then there is an external layer which is called the secondary layer. So this is the specialty of Windows CT. Layer 2 is on the surface of the first layer. Now let me move to the next slide. Own city. This is the construction detail of the own city. So what can you find in case of the own city? Look here. This one is the primary construction. These two primary construction. Then here primary winding, and this is the secondary winding. So secondary winding is there on the core. Primary construction. So this diagram is actually showing us the construction detail of own city. Now here in this diagram, here while operating with city. Okay, so some care we need to take when someone is operating the city. What are that actually? This is explaining, that part is explaining in this diagram. So first one is the city should be 0 to 5 meter movement range, and here this is the close switch before disconnecting ammeter. Okay, so close, we need to close the city before disconnecting the ammeter. Ground city should be ground connected for safety purpose. This part is the current transformer, and the current flows through this part is the power conductor. Power conductor is connected with the city, then city should be ground connected for safety purpose, and to close switch before disconnecting ammeter. Finally, the range of the current transformer is 0 to 5 ampere meter movement range. So the next part I have to explain, that is current measurement in terms of voltage across the standard resistors. Usually currents is measured in terms of voltage across standard resistors. So here in this diagram, look, if you follow, you will find that this is the current transformers. This part now is connected with external circuit QT1, QT2. You can find the voltage V1 from here. The resistance V2 is there in this position. See T3. Okay, so usually current is measured in terms of voltage across the standard resistance. So across the voltage, we are measuring the current for current transformer. In this diagram, this is the connection of CT and PT. So look very carefully. For this part, high voltage power source. Now the CT is connected in this position. Here the load is connected. So precision step up ratio 0 to 5 ampere AC movement range. The CT is grounded for safety purpose. Now here the PT is also connected through fuse, and with the help of this voltmeter we can measure the voltage. With the help of this ammeter, we can measure the current of the CT. With the help of this voltmeter, we can measure the voltage. This is also ground connected for the safety purpose. Here, for CT, the current is 0 to 5 ampere AC movement range, and here for PT, 0 to 120 volt AC movement range. That's a precise step down ratio. So this is the connection schemes of both the CT and PT with the system. Connection diagram. Now the next one is potential transformer. So here potential transformer is basically, you can say, it's a voltage transformer. So voltage example like primary voltage is 7200 volts, the ratio is 60 to 1, or you can say the 7200 is to 120 volts. The standard voltage ratio of the potential transformer or voltage transformer. So you can find a core inside it, and with this the wire is connected, and the ratio is 60 to 1. Now look here, the potential transformer. So it's the construction details of a potential transformer. So high voltage bushing. That means bushing means from where the high voltage side is connected. High voltage coming, that part insulator is called the high voltage bushing. Now this is the secondary low voltage winding. This part primary high voltage winding. So this is the secondary high voltage winding. This is the primary high voltage winding. Now inside the transformer, you all know that for the cooling purpose or insulation purpose, the wire will be there inside this part of the transformer, and this is the core section of the transformer. Now this is acting as an insulation. So this is the basic construction internal part of the transformer. So here points to be noted for potential transformer. The first point, there are 4 points you have to remember for potential transformer. 1, 2, 3, 4. So the fourth one is most important, should not be shorted. Potential transformer should not be shorted. This is one of the most important property you have to remember. Then secondary is usually rated for 110 volt. Yes, usually rated for. So if someone asks you that what is the secondary voltage of the transformer, so you have to answer like secondary is rated for 110 volt. Now design is similar to power transformer. The design is similar to power transformer, but potential transformer are lightly loaded. Okay, so in case of potential transformer, the load should not be very high. This should be lightly loaded, because you know that secondary voltage is very low, 110 volts. How can you increase the load on the secondary side? Now secondary is connected voltmeter or potential coil of the wattmeter or relay. So in case of potential transformer, secondary is connected with the voltmeter or potential coil of the wattmeter or relay. So these are the points you have to remember when you will handle PT. And now the construction of PT. For the same power rating, voltage transformer is costly than power transformer, large core and conductor size. Voltage transformer is more costly than power transformer. Very significant. Why? Because inside it there is a large core and the conductor size is more than the power transformer. So for that reason, the costing is higher than the normal transformer to the core transformer, potential transformer. Now the output is small and accurate, but size is large. Yes. For that reason, size is large. So obviously the costing will increase. Output is small, 110 volt output you all know, but the size is large. Accurate rating you will get from this potential transformer. Now the third one can carry more load 2 to 3 times. Okay, it can carry more load rather than the power transformer. 2 to 3 times load it can carry. And shell type board, that is low voltage, and coaxial winding is there for the potential transformer. So this is the basically the construction of the potential transformer. You have to remember this part only. Now, if we talk about the insulation of the potential transformer, then cotton tape and varnished cambric as insulation for coil. So these two types of insulator is used for potential transformer. One is the cotton tape and second one is the varnished cambric are used as insulation for coil. Second is oil immersed for more than 7 kilovolt. Yes, oil immersed for how much? 7 kilovolt. And the third one is oil filled bushing for oil filled transformers. And lastly, if one side of the primary winding is at neutral, one bushing is sufficient. Okay, so these are the points, the constructional points for a potential transformer. Now, this is the reference, and finally, thank you all for watching the video. If any queries is there, please let me know so that I can clear the concept about potential transformer, obviously the current transformer. Thank you very much.